So our first lesson of Unit 7 is on arithmetic sequences. And this is a little bit different than other stuff that we've been doing in the course, so bear with me as we get started. So the first definition that we are going to go over is a sequence. So what a sequence is it's a set of numbers that are separated by commas, arranged in an order according to a rule or pattern. So it's basically like a list of numbers, but they're all associated with each other because of some sort of rule. So for example, I could have 7, 14, 21, 28. That's an example of a sequence. I could have 50, 100, 200, 400. Again, an example of a sequence. So each number in these sequences is called a term. So when I'm talking about one specific number, I'll be referring to that as a term. Next, the first term, t, is just t or t1, so we'll see both. And then we have the general term, which is t to the n, or the nth term. In other words, that's just a general term so that I could sub in any number for n and figure out the value of that term. So the rule or pattern of a sequence is referred to as the formula for the nth term. So basically what we'll do is we'll put together an equation so that you could find the value of any term of the sequence. And there's some special sequences that we're going to look at that have clear rules, and you can develop a general formula pretty quickly. So there's two ways that I can write out my formula. I can write out my terms, sorry, not my formula, my terms like this, T1, T2, T3, all the way to Tn. Or sometimes you'll also see them like this, so F1, F2, F3. It kind of depends on the text you're looking at, but they're both valid. For us, we're going to be using the first one primarily with T1, T2, T3, but I just want to make sure you see the other one in case you're looking at other texts or something like that, and you know what they're talking about. So let's get into some examples. So for example 1, we have our general formula, Tn equals n plus 2. And we're being asked to find the first 4 terms of the sequence. So let's start by finding our first term. So the first term I'm going to find is T1, and that represents our first term. So all I'm going to do is, instead of writing an n in the equation, I just write a 1. So my first term would be 3. And then for my second term, instead of writing an n, I'm just going to write a 2. So I'll have 2 plus 2, which is just 4. And then I'm going to continue this for the first 4 terms. Oops. There we go. So my first 4 terms would be 3, 4, 5, 6, and then it would continue on. And we write these little ... dots saying that it would continue on forever. Okay, let's do another example. So example B is given in our other format of writing this. So we have f at n is equal to n times n minus 1. And we need to find our first 4 terms. So for this one, f at 1, instead of writing an n, I just write a 1. And that would give me 1 times 0, which is just 0. And I'll have f2. It's going to give me 2 times 2 minus 1, which is just 2 times 1, which is 2. Then f of 3 would give me 3 times 2, which is 6. And finally, our 4th term would give me 4 times 3, which is 12. So the first four terms of our sequence would be 0, 2, 6, 12, and it would continue on. So now let's look at a specific kind of sequence. So those first two were just examples of sequences in general, but now we're going to look at some specific sequences. So this lesson is going to focus on our arithmetic sequence, and then the pre-recorded lesson after this will focus on a different kind of sequence. So an arithmetic sequence is a special kind of sequence where the difference between consecutive terms is constant, or known as a common difference. So in other words, I'm going to be adding or subtracting by the same number each time as I go up. So let's look at example 2, and we need to identify which one of these is an arithmetic sequence. So what I'm going to do is I'm going to see what they are increasing by. So this first one here, I add 3, so to get from 2 to 5, I'd add 3. Then to get from 5 to 8, I would add 3. And then to get from 8 to 11, I would add 3. So because I'm adding by the same amount each time, that is an arithmetic sequence. So I can say, therefore, we have an arith. I'm probably going to spell this wrong. There we go. So now let's try our second one, and let's see if this is an arithmetic sequence. So to get from 1 to 2, I'm going to add 3. Oops, sorry, add 1. Then to get from 2 to 4, I'm going to add 3. There it is. And then to get from 4 to 7, I'm going to add 3. And then to get from 7 to 1, I'm going to subtract 6. So because we're not adding or subtracting by a constant number, that means this is not an arithmetic sequence. So I'll say, therefore, this is not an arithmetic sequence. Okay, so let's look a little bit more into our arithmetic sequences. So for example 3, we are going to now find a formula that represents the nth term of this sequence here, 4, 9, 14, 19. And then once we have our formula, we're going to use it to find the 25th term. So the whole idea of finding these formulas is so that I could ask you to find the 200th term, and you don't need to write out 200 numbers. You can just plug it into the formula and find the 200th term. So let's start by figuring out the formula for this equation. So we have a few terms here. We have T1 is equal to 4, T2 is equal to 9, T3 is equal to 14, and T4 is equal to 19. So let's first start by seeing how our terms are connected. So for me to get from 4 to 9, I'll add 5. For me to get from 9 to 14, I'll add 5. And for me to get from 14 to 19, I'll add 5. So the first thing we've done is we have proven that this is an arithmetic sequence. So that's good. And now let's start figuring out a formula. So how we are going to write our formula is Tn. And this is my preferred notation. You can use the F, but this is typically what you'll see, especially if you were looking for extra help or you're looking for the textbook. This is the terminology you'll see. But if you really want to use the other one, it is fair. Now, we need to first take into account that we're adding by 5 every single time. So how I write that out in an equation is n minus 1, 5. And the reason I have that n minus 1 is because I'm not starting at 0. I'm starting here, and I'm going to add 5 from there. So from my first term, then I add 5. So that's what this means. And then we have to let our equation know where we're going to start. So we're going to add 4 so that we know that we're starting at 4. So that would be our full equation. Tn is equal to n minus 1 times 5 plus 4. And now let's use that to find our 25th term. So now instead of writing an n, I'm just going to write 25. So that will give me 24 times 5, and you don't need to write out all these steps if you can do that math a little quicker. And then when I put all of that in my calculator, I will get that my 25th term is 124. Now from this example, we actually have our general term for an arithmetic sequence. So if you know that your sequence is arithmetic, you can actually find the equation or the formula right away. So our nth term, so the formula to get any term is equal to n minus 1, so my term number minus 1, multiplied by the difference, so that common difference, or how much we're adding or subtracting each time, plus a, which is my first term. So no matter what, if you're given that your sequence is arithmetic, you can immediately find the general formula and plug in values here. We'll also do a few examples of using this a little bit differently. So there's other applications of it too, which I'll show you in a moment. Any questions before we get onto the examples? Okay, let's start with some examples. So for example 4, we have the sequence 30, 27, 24, and it goes all the way to negative 45. So the first thing we need to do is we need to create an equation to represent our sequence. So I'm just going to first check to see, is this an arithmetic sequence? So I always need to check that first, because if it is not an arithmetic sequence, we cannot use this formula that we just put together. So to get from 30 to 27, I would subtract 3. To get from 27 to 24, I'd subtract 3. So it's looking good that's an arithmetic sequence, so we can use the general formula that we just put together. Next, I need to identify D and A. So D was that common difference. So each time I'm subtracting by 3. So my D value is just negative 3. And then A is always my starting term. So in this case, I'm starting at 30. So I can just put 30 as my A value. Now let's write all of this into the general formula. So T of n is equal to n minus 1 multiplied by our common difference plus 30. And if you want, you can simplify this a little bit if you're interested, but leaving it like this is fine too. So now let's do B. We need to figure out how many terms are in this sequence. So we know that 45 is our last term. So what we need to find is its term number. So we're looking for n when our term number, our last term, is negative 45. So if we know the value, we can figure out which term number that was. So I'm just going to sub that in to my equation. There we go. And now let's isolate for n. So the first thing I'm going to do is I'm going to move that positive 30 over. So let's move that to the other side. And when it moves over to the other side, it becomes negative. So we'll have negative 75 equals n minus 1 times negative 3. Next, to continue to isolate for n, I'm going to divide out that negative 3 from both sides. So negative 75 divided by negative 3 is 25. And finally, I'm going to continue isolating for n by moving that 1 over. And when it goes to the other side, it becomes positive. So I'll have 26 equals n. So that means that within these little dots here, we have all of the extra terms. That makes there 26 terms total. So I'd write a little therefore statement. Therefore, there are 26 terms. And that's our final answer. Any questions about that so far? We're okay? Okay, let's move on to our last example. I wasn't kidding when I said that this lesson wasn't very long. So for example 5, the 5th term in an arithmetic sequence is 19, and the 20th term is 79. So the first important thing that they're telling us here is that it's an arithmetic sequence. That means we'll be able to use that general formula set up, which is great. Then we're also given, I'm just going to put these in different colors and you'll see why in a second. We're also given that our 5th term is equal to 19. And we're given that our 20th term is equal to 79. So that's all we're given. And we need to figure out our general equation. So what we're going to do is let's just take the information we're given and we'll just put it into a general equation. So for our 5th term equaling 19, I know that 19 is equal to my equation when n equals 5. So I don't have values for a or d yet, but that's okay. I'll just leave them a and d for right now. And then I'll see once I get all my information if I'm able to solve for them. Next, I'm just going to simplify that bracket just to make our lives a little bit easier. There we go. And now I'm going to do the exact same thing for the green one. So we'll have our 20th term is 79. So our whole thing equals 79 when n is equal to 20. There we go. I'm just going to simplify inside the brackets for a moment. Okay, so now I have two equations with two variables. We can now solve for d and a, and it's up to you if you would prefer to use substitution or elimination, whatever you're more comfortable with. This is a perfect elimination question because I already have the same coefficients on my a. They both have a coefficient of 1. So I'm going to use elimination. If you chose to use something different, that's totally okay. So I'm just going to use elimination. So we'll have 19 equals 4d plus a. So when we do elimination, the first thing I do is I make sure I have common coefficients on one of my variables. So I have matching ones on my a's. Then I stack my equations. And now I need to determine if I'm adding these equations or if I'm subtracting them. So because the signs on my a's are the same, these two have the same sign here. I have same sign, subtract. So I'm going to subtract those two. And so I'll have 19 minus 79 is negative 60. 4 minus 19 is negative 15d. And a minus a is 0. So if one of your variables canceled out and went away, that means that you've done the elimination correctly. So now let's solve for d to isolate d. It's currently being multiplied by negative 15. So to get it alone, I need to divide out that negative 15. So we'll divide both sides by negative 15. So we'll get that 4 equals d. Now we also need to find a, so we can just use 4 and sub it into one of our equations. So I'm going to sub it into our first equation simply because the numbers are smaller in that one. So I thought it'd make my math easier, but it doesn't matter. You could sub it into either. So we'll have 19 equals 16 plus a, like this. And then we need to move that over. So we'll have 19 minus 16 equals a. So we'll have 3 equals a. So now we have the d value and a. So I can say, therefore, our general formula is going to be n minus 1 times 4 plus 3. That was the first part of our question. Part B asks us to find our first 3 terms of our sequence. So our first term is just our a value. So we can just go straight to 3. If you were to go and sub in 1 for this equation, you would have ended up with 3 anyways. So if you forgot that our a value is our first term, you'll still get the right answer no matter what. So T2, so our second term, we're just going to sub in 2 for our n value. So we'll have 1 times 4 plus 3. You don't need to do all of these steps. So we'll get 7. And our third term is going to be 3 minus 1 times 4 plus 3. So we'll get 2 times 4 plus 3, which is going to give us 11. So if you were to do this for a whole sequence, find all of the terms, you would end up finding that our 5th term is 19 and our 20th term is 79. And that is our last example. Are there any questions about this stuff? It's a little different, but once you figure it out, it's actually not too bad to work with.